Okay, so I had a question about finding the power series representation for this function and determining the interval of convergence. This is your guys's problem 1 on your worksheet. So let's go through and do this. So this function looks a lot like the function 1 over 1 minus x. It kind of has a similar flavor to it. So we want to use that to go ahead and write our power series. So I'm gonna just do some manipulation to it first. So we'll split it up as f of x equals 2 over 1 plus x squared minus x over 1 plus x squared. Right? We could also write this as, this is also written as 2 minus x times 1 over 1 plus x squared. In fact, I'm going to do this because I think this is actually going to save me a little bit of steps. Well, I want to rewrite this guy to look more like 1 over 1 minus something, right? So I have that this is 2 minus x. We won't care about this right now. Times 1 over 1 minus negative x squared, right? Because the minus minus turns it into a plus, and we have our original thing, but now we have 1 over 1 minus something, and so we can use our power series representation. So, recall, just in case you don't remember, that over 1 minus x is equal to the sum from n equals 0 to infinity of x to the n. Right? Well, f of x is going to be equal to the sum from n equals 0 to infinity of, this says 1 over 1 minus something is equal to this sum of that something to the n. So in this case, our something is negative x squared. So I get negative x squared to the n. I can simplify this down a little bit. N equals 0 to infinity. Pull out the negative 1 to the n, x squared to the n. I can simplify that one more step. N equals 0 to infinity, negative 1 to the n, x to the 2n. Okay, so that's our power series. Now we want to find the interval of convergence, right? So we need to go ahead and do the ratio test. There's another way to do this, but I'll mention that at the end. Ratio test. So we want to consider an plus 1 over an. Take the absolute value of this, right? This is equal. Well, the absolute value of this guy is just going to disappear, so I'm going to ignore that. I'm going to write as this, as, so an plus 1, we add an n plus 1 wherever we see an n. But notice, this is 2 times n. So when we add an n plus 1, we're going to get x to the 2 times n plus 1. So it's 2n plus 2 over x to the 2n. Okay. And then this, we get some cancellation here. We get the x to the 2n's cancel, and I'm just left with an x squared, right? So I get the absolute value of x squared. Now, if I take the limit as n goes to infinity of an plus 1 over an, well, x squared doesn't depend on that, so the limit is just going to be x squared, right? There's no independence, so if I take the limit, I'm just going to get the same thing. And for that to converge, I need that to be less than 1, right? So we get our radius of convergence is 1, right? Because whatever this thing ends up being less than is going to be 1. So our radius of convergence is 1, but we want to find the interval of convergence. So what we need to do is we need to solve this inequality. Okay, so we want to solve x squared less than 1, right? Well, x squared is always positive, so right, any number squared is always positive, so I can get rid of the absolute value. And I just want to think what x values when squared are less than 1. Well, that's just, it implies that x is in -1 to 1, right? If I graph this parabola, let me drop this real quick. Oop. Let's say this is 1, right? I want to figure out all the x values here, and it's going to be symmetric. We know 1 squared is 1, so this is 1, and this has to be -1, okay? Because it's symmetric. So you can see that a lot of times you can solve these inequalities in another way, but this is the easiest way to do this one. Okay, so this gives us a tentative interval of convergence, but we need to test the endpoints, right? So what was our original series? So our original series is this guy, right? This is the simplest. There's this 2 minus x out front, but that's not going to determine whether the series converges, right? That's just going to change the value that it converges to, right? It doesn't, we care about this sum here. We care about this part, okay? So if it converges in here, then this whole thing is going to converge. So that's all I care about is this sum, okay? So let's test the endpoints. X equals -1. Okay, well then our series, let me copy this up here so I don't have to rewrite this. Copy becomes from n equals 0 to infinity of -1 to the n times -1 to the 2n. Okay, well, anything to an even power is going to be positive, right? So anything squared to the 4th to the 6th, that's going to be positive. So this whole thing right here is just going to be +1. So what we get is we get this series, 0 to infinity, -1 to the n times 1, right? So I can actually just get rid of that times 1. Okay, does this series converge? So this is +1, -1, +1, -1, +1, -1, right? It's just going to be adding -1, +1, 1, +1, -1, ... You might be tempted to say that this is equal to 0, right? Because for every +1, we have a -1. But remember, one of our conditions for a series to converge is that but the limit as n goes to infinity of a sub n, which is equal to limit as n goes to infinity of -1 to the n, this does not equal 0. So this series diverges, okay? It does not converge. It doesn't necessarily go to a finite number, but it's not defined. I can switch these numbers around in whatever order I want, right? Because I can add in any order I want, and I can basically make any number I want with the series. So because of that, it diverges, okay? So, let's see. Okay, so we tested that point, and now we need to test x equals 1. Okay, well, what's going to happen? We're going to get the exact same series, right? The exact same series because 1 to the 2n is still going to convert, or is still going to be equal to 1. So our series is n equals 0 to infinity, negative 1 to the n times 1 to the 2n. That's still going to be the series, negative 1 to the n, and which diverges. Right. So our interval of convergence is negative 1 to 1, not including the endpoints. Okay, so hopefully that clears up any questions. If you are confused, just let me know.